Good morning, class. My name is Rawat Salhab. I am a fresh graduate from Beirut Arab University. Thank you all for coming out today and listening to my lecture. Okay, the subject of our lecture will be big data. I wrote a little outline here to say the steps of what we will be covering throughout this lecture. First of all, what is big data? The characteristics of big data. Why big data? What is Hadoop? What can Hadoop do, and how does Hadoop work? First of all, let's start with big data. Big data are usually data sets that are beyond the ability of regular software architecture tools that can actually process, manage, and collect these data. So, first of all, for data to be considered as big data, it has to be too big, too fast, too large, let's say, is large. Data is too fast. And last, which is the most important amongst these three, is that it does not convene with the regular structure of our traditional database. It does not fit amongst it. The structure, architecture of regular, traditional, traditional databases. Okay, let's be talking about how data is collected. First of all, anything you do on the internet, on your phones, everything it is now collected. Every press, every application you download, it collects data about each single one of you. Every image you post, every video, even your GPS location. Right now, take your phones out. Most probably half of you guys have their GPS on, meaning data is being collected at every second. Where is your current location? And it is being saved. Why now? Because now disks are cheap. You can easily store as much data as you want. It's more convenient right now to actually save these data. Since it is valuable, you can make huge use out of it. You can store it. You can actually absorb the knowledge out of it. That's what you can do using big data. Okay, let's talk about analyzing big data and what does it offer to us. Big data analytics. Okay, first of all, it gives us deeper insight. It allows us to predict what the user wants, what the user needs, what is the user going to be searching for, what kind of product does he want to buy, what does he not want to see online, on his Facebook, when he opens it up. Now everything is possible when you save the data of every user, and you can expect what the user will want in the future. And the second is the broader analytics. Okay, let's write first of all deeper insights, which is the predictions. You can predict what does the customer want. Broader insights means you have a wider environment to work on. You have a huge environment you can work on. Data is huge. You can reach beyond the limit. You can go wherever you want with that. And third, which is frictionless action. No matter what you do, it's frictionless. Now we will be talking about the characteristics of big data. People like to call that the 3 V's, which is the velocity, how fast does the data transfer, how fast does the data go from one place to another. There's the volume, how big the data is, what is the size of this data, and the variety, what type of data do we have. Is it structured? Is it unstructured? Unfortunately, nowadays, like 80% of the data collected is unstructured, and 20% of the data is structured. Barely 20%. That is low. That is really low. 80% of unstructured data is hard. It's really hard to find, to actually go through. Now, some people add 2 V's to the 3 V's that we talked to. Let's write them out first. The 3 V's. Volume, velocity, variety. Variety, we said it's the type, velocity is the speed, volume is the size. Some people add 2 V's to this. 2 V's, which are really important, which is the veracity and the value. What is the value of this data? Veracity, value. The value of this data, the knowledge that is behind it, that is what we want in the end. We want to analyze the data and get knowledge out of it. Okay, now we will be talking about why big data. Okay, first of all, let me make a little space here. Data growth is huge. Data growth is huge, is going really big. It's growing enormously. The amount of data that has been collected for the past 2 years form actually 90% of the data available worldwide. And 10% is whatever the internet has been first created up till now. All the data that has been collected from then till now forms barely 10% of what has been done the past 2 years. Okay, so the first thing is data growth is huge. This is why big data. Okay, all the data that is being collected, it is valuable. All data is valuable. As I said, the knowledge behind it, it has great value. And the disks, what you store data with, has now become really cheap. It's easy to store data. It's no longer hard. It does not cost much anymore. Not like maybe the past 20 years, 30 years, how it's been. Now it's much easier. And the good thing that the growth of data and the growth of disks are proportional. Meaning they are growing at the same time, or like at the same with each other. They are both growing proportionally. This is a huge impact on collecting data, meaning it's much easier and it does not cost us a lot of money to do it. So let's try disk is now cheap. Okay, now that we have that covered, we are gonna be talking about what Hadoop is and what MapReduce is, how does the shuffle happen and all that. First of all, I'm gonna start, this is how Hadoop looks like. We're gonna say that Hadoop is an open source software framework. It is used for distributed storage in different clusters of different nodes. And it is one of the MapReduce, which is a programming model inside of it that reduces the amount of interactions we have inside of each node. Okay, let's say first of all we have this one right here. This is the main computer, the output, where the output is supposed to be. We have the name node, which knows where each file is located. These are the nodes. Each node has its own processor where it's processes on its own to search for a specific file. And this is the job tracker. The job tracker first will be sending the input file to the name node, and it will be asking, where is the input file? Okay, the input file is now located at node 1 and node 3. Now, Hadoop knows that the file is located in node 1 and node 3. So each node will start working on its own, using its processor, searching for that file inside of each node. Okay, great. Now that that has happened, this is where each node will start searching for the file, and once it's found them, listen, the most important thing is that these nodes work in parallel, meaning that this will not affect the second node and none of them will affect each other. They work independently on their own. Node 1 have found, let's say we are searching for an image inside of these nodes. Node 1 will find the image, 1.jpg, and node 3 will find the image, and it will be outlining it back to the job tracker where it will send it to the output file. Okay. What can we do with Hadoop? It is not limited to this. You can do statistical data analysis. Let's say you want to compare the difference between maybe how high the economy is and how low it's going to be depending on population and all that. You can do all of these statistical data analysis. You can do machine learning. You can do much more. Hadoop has no limits. Once you have the data, Hadoop has no limits. You can go wherever you want to reach with Hadoop. This is how it works right here. Okay, now there's one problem. Sometimes between nodes, there has to be communication. They have to talk with each other. They have to say that I found this file, I didn't find this file. They have to communicate. Okay, one more thing is that inside each node, data is replicated so that we can achieve reliability. That if one node falls over, we will not affect the result. We will have the same result. We will achieve the same result, thus achieving reliability. This is how reliable Hadoop is. This is how much you can depend on it. Okay, we're gonna be talking about MapReduce, which is a function inside MapReduce and how it works. Okay, let's say we have numbers here. We're gonna be needing to count these numbers. There is 1, 2, 2, 3, 3, 2, 1, 3, 1, 1, 3, 3. Okay, so each one of these nodes will count, will separate the values inside into key value. Key is a number that is being repeated, key 1. And the value is how many times this key has been repeated. In this case, it has been repeated once, so the value is once. Key 2, value 2, since it has been repeated twice. Key 3, value 1. Same for node 2, key 3, value 1, value 2 actually, it has been repeated twice. Key 2, value 1, key 1, value 1. The same goes for node 3. They are all gonna be reduced to the local output, meaning, first of all, there will happen the shuffle. Each node will shuffle the keys, each key will go to a different node. So all key 1 values will go to node 1, all key 2 values will go to node 2, all key 3 values will go to node 3. Now, once they are in key 3, this is where we do the reduce. This is where all the values are summed up and written to the local output. I hope you've all understood. Now, one last thing, why big data? It helps us understand and target customers, what they want, what are their needs, what will we expect from, what do they want in the future. We can expect it, we can do it. It also helps us to understand, optimize business processes, everything related to business products. We can optimize it, we can make it better, faster, and more efficient. This is how good Hadoop and big data is and the uses of them. Thank you all for listening throughout the lecture and for your constant concentration. Please, if you have any questions, ask me after in the office. Thank you.